Cool. I think what we'll do is we'll start, Andrew, and then I'll keep letting people in as they come through, because I know there's a few people who are messaging me now saying that they're just about to join. So, yeah, thanks everyone for coming today. Appreciate you taking the time. Hopefully you can get some good insight from Andrew today around kind of Kubernetes and so on. I'm Jack Moore. I'm one of the directors of WeShape. So Andrew, I'll kind of do a bit of a quick introduction into who we are and what we do. I'll pass it over to Andrew to run this session. So yeah, WeShape, we're a DevOps, digital, data, and cloud consultancy. We have, I suppose, a bit of a unique operating model compared to most consultancies, where like our core team is made up of both kind of technical consultants and ex-industry kind of recruiters, which it enables us to kind of, I suppose, identify technical pain points and kind of build solutions and build teams rapidly behind that. So yeah, these are some of the customers that we've worked with so far. Next slide, Andrew. So some of our solutions, I suppose what our main focus is around kind of organizational and technical advisory, squad implementation, SME consultants who can effectively kind of parachute into certain projects and add value in their respective fields. And we also do training and coaching as well. Andrew, do you want to next slide for me? We're also behind a large number of kind of technology community events. So I'm one of the organizers of London DevOps. It's kind of mainly focused. I know there's probably a few people in this workshop who has attended that event themselves. But yeah, it's mainly kind of practitioner led. We're also behind the London Tech Leaders community, which is a kind of peer-to-peer platform for kind of CIOs, CTOs to kind of share ideas, be innovative, and obviously kind of collaborate on certain areas. So any interest around kind of these communities at all, just feel free to drop me a message after the workshop. Next slide, Andrew. And I suppose lastly, I suppose WeShape's kind of core focus is kind of around kind of guiding and shaping technology strategies. So around kind of process, tooling, methodologies, etc. We kind of pride ourselves on the kind of accelerating technical and product delivery as well. So kind of paired teams to work alongside internal engineering teams. And one of our core focuses is obviously upskilling internal capabilities for our customers as well. So any questions around WeShape, just drop us an email or a call. I'll pass over to Andrew without further ado to kind of run you through kind of Kubernetes. So yeah, Andrew, over to you.
Beautiful. So essentially, I am one of the consultants working at WeShape, working on a number of bits and pieces here and there, actually. There's always something going on. And I'm going to be presenting a really, it's high level, dipping in at core points of the actual presentation of the technology and all the auxiliary technologies around Kubernetes. So going into that, we're going to be covering a few topics. We're going to be going over containers, which are all Linux-based containers. They're really the heart and soul of Kubernetes, because Kubernetes is a container orchestration platform. It's what you're essentially orchestrating. So we'll cover containers. We'll also cover everything that makes Kubernetes what it is at that high level. So all the components, how they're organized, how you interact with it, and how it works. We'll also talk about why you should be running Kubernetes, and also when Kubernetes is the right thing to run. And then just some final notes, because obviously it being quite a multi-layered technology, there's so many different ways to approach it, so many different areas. There's a lot of opinions everywhere about it. And it gets lost in the noise. People don't really quite, not many folk, in my experience, have really delved into like, this is what we're actually doing. And there's a lot of pressure to get selections, whether it's tool selections or to even get on the platform in the first place, from various different bodies. That really muddies the water, makes it a bit confusing to pick up. So there's some final notes there, but this summary will hopefully give you a really good introduction to what it is, why you should be using it, and really when it fits best. So moving on, Linux containers themselves, they're the core. They're the real core of it. Like I said, it's all about orchestration. So when we have an application, or an environment, and just really breaking down to the bottom level. What we've got underneath it all is a computer, one of these little things. So this is a Raspberry Pi, and just getting really, really back down to basics, this exists outside of software. And this is what actually does all the computation, all the important stuff. This is what gives us the value. So we're chucking 5 volts into it. This smaller computer, obviously larger ones, they get the whole 240 volts. If you want to talk out to the network, talk out to the internet, you need to shoot electricity to this thing. If you want to save data in a physical format, you need to start putting stuff onto this SD drive. There's a whole bunch of physical stuff that goes on in the real world, which isn't just your software environments or the application sitting on top of it. There's a thing in the middle that needs to take all of that and turn into actual real life stuff. And that thing's the Linux kernel. So the Linux kernel is this rather large piece of software that integrates with the hardware and the software side. And the software environment doesn't go anywhere near the hardware in Linux OSs without going through the kernel. Most it can do is play around in its own memory. So it can sit in its own memory, it can assign things, it can do addition and stuff like that. But ultimately talking to RAM, talking to hard disk drives, talking to a network, anything like that, it has to go through the kernel. So what does that mean, and like, why is that important? Well, the important thing is because the kernel's in the middle of it, the kernel can actually control what processes have access to. So in this case, what we're doing is whenever you get a query coming through, you get an application wants to talk to someone on the internet. What used to happen is the kernel would just honestly and truthfully answer. And this is a holdover from olden times where code wasn't long enough for you to have to really worry about that thing. You could just read what you were running. And it's the same deal with why we had unencrypted network traffic. That's not practical these days with the sheer amount of code and libraries and everything else that we have out there. As such, what we can do now with a very, very recent feature in the Linux kernel is to basically add labels and categories and namespaces to the applications that we're running and then control those namespaces. So the kernel can now give contextual answers rather than full answers. And that's what containerization is. Containers are literally just putting your applications in a single namespace, but across multiple areas, such as what users you can see exist, what processes you can see exist on the computer, what you can access and so forth, what files. From there, the kernel will give you contextualized answers back. So that's still a bit obtuse, basically, but that's essentially what containers are. They're contextual answers back from your computer. So why do we do that? What's the point? Well, the real major benefits, and there's 2 benefits to it, and that is that the first one is really, well, it's more bundling than anything else. So when we have a container, we can package it all up, not just all the files and everything. So going back to this, because we know what the container has access to, it's also very, very easy to capture all the files and all the code that that container is relying on, package it up, and then be able to lift it and shift it around different Linux-based operating systems. And that gives us portability for applications as well. So that's the big use case, bundling up your software so you can capture all of the stuff which happens to be sitting in the software environment. You can tell what it accesses, you can tell what it's not accessing, and you can just grab all of it, and then you can just dump it in a completely different server, and it will run. So that's the big one. But the major one, for me at least personally, is that security aspect. So you can isolate processes, you can restrict the file access, you can make sure that things are private, processes are private, and then you're a lot safer in running software. So if you run it in containers. So just to really illustrate that, here's a piece of code I wrote. You can even do it in one line. And I've got that one line in there, but I've got a prettier version. And what this will do is when I run it, it'll go through and it will go ahead and start basically trying to steal my AWS credentials. So that one line will just print all of my AWS credentials to, my monitor. I'm not going to do that because that would be stupid. Whereas the longer version will do the same thing, but it will censor it and just say, hey, look, these are the accounts that I have access to. And then what I do is I simply run that on my machine. It's called Dodgy Snooper. It'll go up, it's found all my AWS credentials for my default account, a few other accounts, even some accounts we're working on, at WeShape. Obviously, this is all secure on my machine, it's just an example, but it's showing that if I just run this code raw, which could easily be just that one line up the top, one line of code raw, it'll find credentials for everything. Then if I run it in a container on the exact same machine, very, very close afterwards, it can't find any details at all. And that's because I've not given my Docker environment, that container, access to the underlying files and credentials. So in a full, just completely there, full transparency, there's all the code. If I run it outside of a container, it's got access to my full machine. It's essentially as if I was running it without being in a container. When I do run it in a container, it can't find all that sensitive information, which is really important. This is everything that you would need to export data out of the AWS environments. It can get really quite sensitive. So as a general rule, we should all be defaulting to running processes in containers. If not for the ease of bundling, absolutely for the security aspect. There's no reason why we should have a single line of code just being able to have access to whatever, which is the default for most Linux operating systems to a degree. I know there's different things around user access and things like that, but practicality wise, it's just so much easier to contain things and then add access rather than to start running into issues with SE Linux and other things as well, which often aren't very well managed. So as a whole, pretty much every organization, and even really to a case, our own personal machines, should default to running in containers to protect ourselves. It's a safer way to run in code. There are some exceptions. Adding on, especially with Docker, adding things to containers, you will take a hit on your network input output. And sometimes you just don't need it because everything on the machine is dedicated to one particular task, such as if you're running dedicated servers to one dedicated piece of software, you know all the code in there and it doesn't really matter. That's okay too. That benefit won't manifest for you as much. And if there's problem applications which just haven't been ported to containers, that's always going to be a problem too. But those are exceptions. The real rule is we should be running in containers. So if we're running in containers, the best thing for us to do is to orchestrate them. And that's where Kubernetes comes in. Now, there are other orchestration options. Obviously, you saw in that last example, I just used Docker run. That's fine, but then that only works on my one laptop and it integrates with my terminal, and it's still not quite orchestration. It's more just execution. So if we talk about the other options that we have, we've got a large scale of Docker called Docker Swarm. That is essentially a direct competitor to Kubernetes. You can also run systemd and your old original management processes for running containers. However, that's not going to scale up in the same way, and there's better ways of doing it as well, because what we really want is we want to have multiple machines and we want to be able to scale out horizontally. We want to be able to scale out those machines as well, because if we're running everything as containers, there's going to be a lot of stuff. So Kubernetes is the de facto way of doing it, and it's got the largest mind share, so it's what we really want to use. So what does it look like? Well, we'll get to that in a second. The most important thing is the fact that, remember, this is orchestration. So Kubernetes is not going to do everything for you. It's not going to provision all of your basic machines. We still need to install Linux on it in the first place. For example, we still need to install Docker. It won't do the images. It won't do everything. It's very much about orchestration. And that means that it'll allow us to run things in certain ways. And that's about where the barriers start to end. And we should still have at least a wider environment that we need to manage. So within that context, we'll talk about what Kubernetes does do, what it doesn't do. So this is what a basic Kubernetes cluster. Pared it down quite heavily. I've given you an example of a master node, a worker, load balancer, and even how you interact with this on the left-hand side there. And this is essentially all it is. It's a bunch of binaries that sit on machines, talk to each other, And as they talk to each other, it formulates out a cluster. There's not that much stuff in there in terms of individual little components, but they're all absolutely core to it. And it's important to know exactly what they're doing. So in this regard, this would just be a bunch of Linux servers sitting in a network where they can all freely talk to each other, maybe on a subnet, maybe on a home network, or in a cloud VPC, something like that, where all of these machines, these little machines here, can talk to each other. And then we outline two sorts of machines. We've got master nodes, also known as control planes. Those ones, technically, you wouldn't need to worry about unless you're on-prem. If you're in cloud, the master nodes are literally what you are being provided as a service. And then we've got our worker nodes, which are just the workhorses. They're a lot simpler. So, delving into it, the important thing to note is that we all, every last one of us, from engineers to dashboards to the nodes themselves, only talk to the Kubernetes API, which is sitting right in the middle there. And the Kubernetes API sits on the master node, the control plane. You can have multiple control planes, and they all have their own instances of these applications, and then they all cross-balance across that. So you can have multiple master nodes, but we're just having one for now, and that's where our API is hosted. And the API is exactly a traditional API. In fact, it follows open API specifications, and that's where all your client libraries come from. And all you're doing is you're just sending HTTPS requests to it with some JSON in. You authenticate, it looks at your requests. If it's happy with it, job done. It'll parse it, make sure it makes sense. That's it. And all of these particular systems over here, from kubectl, which is a nice little interface that makes those requests for you, to K9s, the dashboard, Helm, and Customize, all of these things, all they do is just make HTTP requests to the API. And then inside your master node, the API communicates out with the other elements of that control plane. So we've got a controller manager, we've got a scheduler, we've got a cloud controller manager. These pieces all handle the different elements of really orchestration. So your scheduler will choose what pods and what workloads are going to which workers. Your cloud controller manager will go ahead and have a look at anything that comes through. It's actually a little extension on top of core Kubernetes. You won't have it if you're running on-prem, but if you do have it, what it will do in an AWS environment, for example, it'll sit there and it'll see anything that looks like a load balancer that comes through, a load balancer resource, or anything requesting a volume. That's the thing that goes ahead and provisions the underlying AWS infrastructure. And you've got one for Google Cloud, you've got one for Azure, you've got one for OpenShift. You get different CCMs, and they all handle their individual bits and pieces to help support Kubernetes in the cloud. And then you've got your controller manager as well. That one deals with all the other kind of aspects of Kubernetes which aren't handled elsewhere, which is a really wide definition, but it does do a decent amount. So anything that isn't handled by the cloud controller, so anything specific to Kubernetes, that's kind of what's dealt with there. But I'll circle back around to that at some point, and we can delve into that because that's one of the larger aspects. But that's the main piece here. Everything talks to the API. The API has these other engines surrounding it in the control plane, and those other engines are really the decision makers as to what goes where, your scheduler, your cloud controller, and the rest of your controller management as well. And then we have all these various other nodes that they talk to. Those nodes communicate back to the API as well. So the difference between a worker and a control plane is the control plane by default won't do any work, which is part of the reason why when you buy it from a cloud vendor, you get a flat fee, because it's not going to scale up. It just orders your workers what to do. So there's no point in really scaling about it, worrying about it. You can adjust that, but it's not recommended. And your workers are the things that really do a lot of the work. And all they have sitting on them is a kubelet, Linux, your container runtime, which most of the time is going to be Docker, although there is Cryo and other options as well. But essentially, a kubelet application sits on there, talks to the API, gets its instructions, reports back on the state of things, and then makes things happen on the server. So if you remember when I spoke earlier, Kubernetes orchestrates, but it doesn't just build a machine from scratch. You're still going to need to load Linux on it. You still need to put Docker or Cryo on it. You're still going to make sure it's got appropriate networking. And then once that basic server's there, you install a kubelet on it, essentially. That talks to the API and kicks off all the container running, the actual running of containers. And works are really that simple. The other elements of it that are really important as well is two helpers, really more than anything else, which persist on every machine everywhere. So they're on masters, they're on workers, and they are etcd, which is this little cog fella down in the corner. That is a distributed database. So when you provide stuff to the API, the API does need to remember it. So if you give it a manifest with a bit of data in it, that's where that's stored. And that's distributed everywhere. So that makes it so you can drop servers out of your cluster as you like, and the cluster still maintains its knowledge. You don't just suddenly lose all of your config maps and secrets. And like I said, that's everywhere. You should basically never have to touch it. It runs exceptionally well. There are occasions where you will need to deal with it, but otherwise you can take it for granted. And the other one is the queue proxy. And the queue proxy is something that sits on every machine. So every last one of these machines here will have queue proxy on them. And it's the thing that allows you to access any pod across any of the cluster and be able to hit it as you need. So with Kubernetes as standard, you get DNS and networking included. So the cluster itself will have its own IP network range, which means that every pod, every service in the cluster that you define, if you're running an application and you choose to want to expose it to the rest of the cluster, you can provide that. Tell the cluster, I want you to expose this service. That service will be exposed, and then you'll be able to hit it over a fairly standardized DNS, so that no matter what you deploy out into the cluster, it can all talk to each other as you wish, and queue proxy facilitates that by providing proxying across every machine. So now you don't need to worry about your nodes. Your nodes are something in the background. It's hard to even distinguish between which one's which. And the final thing I put on the top is a load balancer. Now the load balancer is important because it's how you control external traffic coming to your cluster. Whenever you do this in the cloud, this is actually what cloud vendors do when you run an ingress or create a load balancer service. They actually put a load balancer, and then it uses node ports to come down and hit your actual services in the cluster. That's the theory. It's really important to actually see some good examples. So what we do, and the only thing that we do, is we just talk to the API and provide it with code. So like I said, HTTP, JSON, and then all of these elements in here, these elements within the master plane, take our input and keep it going. So they go, right, you have given me a manifest. This manifest says that you want to run this application. You don't want to not run it because you've only told me that you want to run it. So we're going to keep it going. If a node drops out, we'll move it. We'll make sure it's got everything there. And that's what your control plane is really doing. It's taking your instructions provided by queue control or anything else and ensuring that the cluster matches those specifications. So this is all theoretical. Let's kind of look at exactly what this is. So here I have a full, and I mean full deployments of MySQL in just these 3 files. So we've got everything set up. We've got our cluster there. We've got an API. We've authenticated to it. We've got pods. We've got all these other new terms. This is where you get the benefit of learning what you've been learning and implementing. And that is really, really simple. I've got a deployment for a MySQL database. It has, I've selected a node for it. You don't even have to do that, but I've done that. This is real life, by the way. This is literally the configuration. I've got, it's running 5.7 due to an application requirement that I have elsewhere. I've set the root password, and I've even given it a permanent storage space as well. So this storage space is essentially to make sure that if it goes down, we don't lose the ephemeral nature of, remember, we've got the file access. This is providing a permanent space for MySQL to store its data. And that's what this middle file does. So that little bit at the bottom of the deployment links to the middle file in the middle there, which is literally persistent volume. It persists. I've given it 20 gigs of storage. I've put that on the actual server itself. And then I back up externally for that, but more on that in a second. And then I've made sure that there's only one pod that can read or write to it at once, which is this deployment. So the data doesn't get corrupted or grabbed hold of. And on the third side, this third file here, I've exposed that service. So there's two services in this file. The top one just exposes port 3306 to everything else in the cluster. So no matter what the name of the deployment is, no matter where it's loaded, we can access it over the DNS of literally MySQL or MySQL.default from anywhere in the cluster. So any application on any of the machines can hit MySQL. And then the second service is making this available externally on any node in the cluster via node port on port 30,066. So that's a bit like exposing over a load balancer, but it hits on that specific port because this is an on-prem installation of it. And that's it. That is literally a fully blown persistent volume store installation of MySQL 5.7. And we're done. And then that will maintain. This one in particular has been running for about 2.5 years. Never had to worry about it. Applied it out. Once it was done, it was done. But this is only part of the story. What we also want to do is now we've got the database up, we want to back it up. We want to know what the backups are. We want to make sure that they're going to the right place. Okay, well, that's pretty easy too. Here's the same cluster. Up the very top, you can see MySQL 886. That is the literal application from this previous slide. You've got a MySQL backup job, which is running. That's been completed. That's been on a cron job for about 2 and a bit years as well. And then we've got a chatbot called Smashbot, because he's a little legend, who is a JS API. So he is a node-based application. I'm trying to remember Express. That was it, Express Web Framework. And he's just sitting in the same cluster. He hooks up to Slack. And once the MySQL backup cron job is done, it pings another service for Smashbot, which is literally just smashbot.default. Pings him a HTTP response with a full summary of, here's all the databases that were backed up. It was at this time, and it's been encrypted and sent off to S3. And that has been running once again for years. It's been there, it's been done. These machines have been upgraded, reinstalled, and yet because we told the cluster what we want, MySQL database with a backup on a routine and message our Slack chatbot to let us know when that's happened, it's been running like this for years. So that's really the power that you get out of Kubernetes. A lot of the tedious stuff that you get from deploying out and managing is abstracted away. So you define what you want, you need to know what you want, and you need to put them on machines that you've appropriately set up. But once you've done that, you can condense down your deployments into a very, very clear manifest, which doesn't need to be massively big either. This is literally everything there, and you can get deployed out. And then Smashbot and the backup were only about an extra 180 lines in total between those two. And that's what you're winning here. And then because it's available, this is the other thing. When we had the session last week, we were talking about CI/CD, which is the big challenge in a lot of organizations. The only thing that you need to do is control and deliver these files to your cluster. Now that means that you can do GitOps, so you can just give these files to the API. You can do many things. The bottom line is, this is all you need. So now the flexibility is on what's best for your organization to get it out there. And that's where you're really winning with it. And that's why you find so many different variations of it, of deploying out to Kubernetes, purely because it's done such a good job of all the tedious stuff that you're left with these few small but powerful files. Now you can pick what's best for you in terms of getting out there, and that's where you get so many permutations of CI/CD in Kubernetes. But this is where you really win with it. And don't forget, you've got all containers underneath. So this MySQL database it's going to take a lot more to compromise it than if I just ran it as an installed application on a plain server. So you win with the containers, you win with this here, which is really the mother lode in value that you're getting out of it. And once it's all up and going, you can then really start to build off the top of that and have a full cluster of services. So how do you move through this? What do we do first? Well, if you're not at the point where you're containerizing things, I would say you probably should. Even if you do come under those situations, like you're running high frequency trading software and you can't take the hit on networks, if you're running in Docker, which is a totally valid use case, you should probably containerize it anyway for easy development. Team onboarding, local environment setup is all a lot easier. You get to see what's in your applications. You get to make sure that you don't have any, or it's a little bit easier to control security. And it gets you to understand your container runtime if at some point in the future you do move over to Kubernetes. And let's be frank here, even if you were a high frequency trading firm, not all of your applications are high frequency trading. So there's going to be some things which will probably be better managed in a Kubernetes cluster anyway, reports and all the other elements that you have of auxiliary services around that. So I can't see many organizations where they just will not get any benefit from Kubernetes or containers. And then once you've containerized it, because this is something that Kubernetes won't do for you, that's something you need to pick up on your own side. You can give it a go and you can find out, right, okay, now we've got things in containers, when you start deploying them, we can start playing around with how well does it fit into our organization. Okay, so do we have a place for our container images? This is a big thing I've had to deal with at banks who are a little bit slow to pick up new tech, but they don't like the idea of container images being stored in different places, and then you have to ask and answer those questions. So that will come out of your containerization process. And it'll also allow you to really understand, right, what data and what sensitive information we're putting in our applications, because you can't really be baking sensitive information into an image. It goes into essentially a code base. So Docker files, for example, which are the manifests and recipes for your containers, you can't really be putting passwords in them. So that will also spark off the right sort of conversations as to where do we put our sensitive data? How do we deploy it and encrypt it properly? And then it gives you a bit of visibility as well. So if you end up in a situation where you think it's one application, but it's actually 2 or 3 that are run off a bash script or something, some real kind of gnarly technical debt, that's the sort of thing that'll come out of your process with containerization. And then also explore your options. As part of giving it a go, you can really find out, right, who can do what's best for me. You'll find all these wonderful technologies out there. So yes, you can store container images on Nexus, which is a really, really common artifact repository. Or you could look at external cloud services. You could look at other ones. The most impressive one, and the one I'm really quite proud of, is that you can actually get your, we have put together a production and development and pre-prod environment on DigitalOcean for a grand total of $72, including tax, a month. And a good chunk of that is a Kubernetes cluster, which doesn't even cost $10 a month. And if you weren't exploring options, you wouldn't even find that. But it's there, it works. Here's the receipts. Up in the top right-hand corner, pre-prod ops cluster, $9.68, not even $10. And that is running backups. It is running health checks on our production server. And these are the sort of things that you can do. So it's also an option to really change up how you approach things as well. So that really is the majority of everything. It's a nice step for you to be able to get away from some of the older, less mature patterns and the way of doing things that we have, such as applications, bash scripts, logging onto a server, shelling in and doing things, and really isolating your applications into what they are, making them available in the right way, and getting them into a really premier, really good, solid orchestration system. And that orchestration system will work really, really well so long as you're very aware of how it fits in and what you need to provide, which is appropriate orchestration of servers you can run, which means you can spin it up, you can remove them out, that your applications are properly defined as to what they are, what they need to be, what ports they're exposed on. And once you have started down this journey, what you'll end up with is a much cleaner, much more secure environment, and can integrate into your firm as you need. So the final thoughts are really check your use case. Not everything's going to fit very well onto this. All of that stuff I've talked about in terms of hygiene, some things are just not worth fixing. And that's where the experience and really a second opinion would come in quite well. Just to confirm that, run a few trials, see what happens. And secondly, it's not always the be all and end all. So whilst we have so many different opinions and you have so many different companies that are trying to build on top of, you know, deployments, pipelining, everything else, just remember back to, this is only a couple of hundred lines to get a full MySQL database in there, and complicated applications won't get that much larger than this anyway. So with that in mind, just think about not everything's to be all and end all. You can pick and select what you want out of this. You could run a Kubernetes cluster, as I had up in the first slide. You could run a full cluster here with all your services. Then your high frequency trading software could be elsewhere and talk you through a load balancer. You can pick and choose as you like. You don't need to go for the big bang, and you can define your own boundaries, what's going to work best for your business, and go from there. And that really brings me on to your last point. You might need help. You probably do need help. I needed help. I went off, I got trained. I started playing around with my own stuff, took it to a larger size. And that's all experience which no person by themselves can really pick up. So it's easy to get, if it's not the actual work, just a second opinion to go, hey, we were thinking of doing this. Will this work? Do you think it'll work? Where should we draw our boundaries? How do our steps flow through this? Because it's going to be quite a heavy cultural change depending on where you are, because you're not just tackling Kubernetes, you're also tackling a better way of doing things as well. Better CI/CD, better manifest, which actually dictate everything that your applications is and are, and a process to get that out in a way that's really visible to everyone. And it's a struggle to begin with, but once you get there, you have a better life out of it. Like, I've put manifest into clusters which have been running for years, and that takes away a lot of the stress, a lot of the strain. You don't need to worry about servers going down. You don't need to worry about all the other things that make people's lives worse, if we're being honest. This is just a better way of having a better culture, a better business, and a better, really, state of play for all of your applications, which is why it's used in so many places. It's why we're using it a lot of the time, but only when the case is right. And that's where you might need a bit of advice just to work that out. Just an idea, just water bounce some ideas off. So you can contact us directly, you can speak to the team, but I'm about for another 20 minutes or so, so I'm happy to take questions.
Yeah, hi everyone. I was just going to say, you can all feel free to kind of turn your cameras on and unmute yourselves, and any questions that come to mind for Andrew, just ask him. He's happy to answer anything you might have around the kind of presentation or your own personal experiences.
Yeah, Andrew, I wouldn't mind just quickly asking, what's your views on the various sort of Kubernetes as a service options out there, and what use cases would you look to considering leveraging that rather than running your own Kubernetes cluster?
So the major thing about it, and it's a good question because it allows me to really expand on, is that when you get a managed service Kubernetes, the vast majority of use cases I've seen, you only get the master nodes, the control plane, and that's it. So you still need to be able to run your own servers. Now, obviously with AWS and AKS and other things, they'll handle this bootstrapping for you. So you don't need to worry about the workers, but ultimately you still need to be able to work out how your workers scale. You still need to control your IAM access. And that's where it comes down to what's with your business. What has your business chosen your cloud provider for, and why? So if we're talking about AWS being the dominant one, a lot of companies are already baked into AWS via a single sign-on or have a process for actually getting people to have access to, bits and infrastructure in AWS. If that's the case, then AWS could work for you. I like DigitalOcean because it's a much more pared down version of AWS, but then that's for smaller projects. For larger projects, AWS, we need that full feature suite. And then that's the same with AKS as well. So if you're asking me for, I don't know, a score out of 10 for each cloud provider, they've got a much bigger legal team than I do, so I'm not going to do that. But what I would say is you might not, it might not have the difference between each of them are so much smaller, you're probably in a better situation to go with the other stuff that you might not have thought of, which is like the identity and access management, billing, like is your finance team going to accept invoices from a company that they don't know about? These are the sort of things that can get a bit awkward. And I bring up DigitalOcean because at least with DigitalOcean it being $10 a month, wow, that means that you can get every guy in your team an account. They can do whatever they want with it and it'll fit on a company credit card. That's actually the lightest, smallest step in there, and then you can scale up from there as you need.
Yeah, I guess kind of it was more, under those managed services, what are you still left having to manage? So you've touched on that, which is really useful, because often they're presented as, takes away all the pain and, sort of is an easy entry point. But, clearly there are still things you need to manage. So thank you for that, Andrew. And thank you for the talk. Really good.
No worries. And like I said, there's actually other options as well. So you'll still need to manage things, but you've got other things such as Chaos Cops, and you get K3S. So running your own mastered control plane is not too difficult, but it's just that you need to get those other processes around. Remember, it's orchestration. You have to play conductor. So you can't escape that. This won't do that. And that's the major thing with technology of the day, which always irks me as an engineer. Someone's always promising, oh, it's amazing, it's a miracle maker, it's fantastic. Well, the sort of stuff that is baked into Kubernetes are quite simple. If an application dies, it'll attempt to restart it however many times you want it to restart it before it gives up. So if MySQL died for some reason, I don't know why, it's mostly reliable just because of the containerization, but if it died, it'll try and restart it 3 or 4 times and then it'll just give up, and I'll have in K9s a great big red crash loop back off failure, and then that's where the Kubernetes needs to get involved. So the automation of things is something that we all need to kind of accept, because we do need to make decisions at times, and that's where Kubernetes comes in. It fits into the slot of the really, really obvious things. If you can just restart it because it's had a memory hiccup, do it. Great. This is what I want to run, put it on a server I own somewhere where I can reach it. Great. That's what it will handle. The overall process and what you want and accept and like, all the other stuff, you have to build extra around it, because the stuff Kubernetes provides is common use cases.
Okay, great. Thank you.
Does anyone have any other questions? I know I'm not sure, Vinod, I saw a question from you on the chat. I can read that out, but I suppose for Andrew, it says, what would you say are the barriers for adoption in organizations at an enterprise scale?
Compliance. It depends on your enterprise. Some are going to be more compliant than others, but when I was working at HSBC, I did the ForgeRock pilot. ForgeRock's an identity and access management, and it was for open banking. So open banking, this is all public information, by the way, so no one's getting kind of leaked out here. It was all based on AWS, and ForgeRock at the time were pushing Kubernetes and specifically Helm as a way to deploy it out. So I built containers, and I got containers, and it was all good, but then I couldn't find a place to put those containers where security was happy with them. So I ended up exporting them as a image, which is literally just a tar, a zip, putting them in S3, and then writing my own bootstrapping scripts so that the images were already on the machines and didn't need to pull from anywhere, which was the compliant way of doing things. It's also a little bit insane, because I basically wrote a kind of ad hoc, really low level, ridiculous ECR, container registry. So that's the sort of thing that you can do it, but let's be real here, it's going to be a showstopper. And so that's why I put compliance at the top. But shortly after that, what I would also say is, let's be frank as well, resource, right? Everyone's run off their feet a lot of the time, especially engineers. You used to have servers, now you have EC2 instances, and then you've got, you know, Google's version, AKS's version. You get so many other things that you have to learn and then deliver on as well, and really push for, because your time to market is so important, that now you've got Kubernetes on top of it as well. It's a lot harder to pick up all of these different elements and approaches and culture and methodology of doing things when you're still needing to get stuff out the door in a way that is how everyone's done it, which means that you won't get into fights with people, if we're being honest here. So resource to actually go and pick this up and then be put through the change, and compliance as well. Compliance is the one which is a total showstopper, and then the resource aspect is just more the practicalities. And that's why trying to tackle everything could be quite different, which is why this is pretty much the only presentation where I go like, hey, look, you could probably need some help with this because Kubernetes is in its own level. Whereas the SRE presentation coming up, it's like, yeah, you can bounce a few ideas off us, but reliability is as you define it. So there's not that bit at the end where you're going like, hey, you should look to outside sources to get some guidance. Kubernetes is much more so, because it's a definite change for so many organizations, not just in what they're doing, but how and why they're doing it. So hopefully that answers. It's a double answer, I'm sorry, but it's kind of, they're hand in hand.
Hi, Andrew, can you hear me?
Yes.
Lovely. Thanks for, bringing out some points around compliance, and particularly about the skill gap. I just want to kind of give a further dimension to it as well. One of my experiences that we are constantly seeing when we do enterprise transformations is consistency in terms of enterprise strategy, how to deploy microservices across business units. So we have seen microservices go out of hand. There's no real documentation when it comes to service mesh, things like that, in terms of how each microservices, what they do, how they kind of interact. So it's becoming a little bit more chaotic and anarchy at an enterprise level. It's all well and good at a business unit level or a structured functional unit, but when you try to work across business units, microservices are have to be dealt with a lot more caution.
Yes, absolutely. Yeah, and I do have opinion on that if you'd like to hear it.
Go for it.
Excellent. So you don't is basically the aspect here. So if I were to, I always like coming back to architectural terms, because I find that good software is built in the same way that construction is, good construction is. And you get a few weird use cases, but ultimately, when I am building a house, where I imagine my house has phone lines, electricity lines, water pipes, and those systems, they exist in the same physical building, but they're separate except for where they need to meet up. So my electricity cables do not run taped to my water pipes, and they don't follow the same lines throughout the house because they're different. And then at certain points, they will hook up with, say, the boiler, which is pretty much the only point where the electricity and water, matches up. And that's how I feel that no matter how big the house is, you would keep a similar system. You might even just break down the different areas of the water and the electricity, so you're not running massive amounts of cable. But that's about it. That you keep those individual systems separate because of what they do. And I feel like microservices and Kubernetes allows you to do microservices for sure, but that's how this should work. So bringing it back to this, I really do feel that multiple clusters is the right thing to do in more situations than it's currently implemented as. Because what I do see is I see a lot of organizations where they go, right, we're going to take a whole company worth, our whole platform is going to be in one massive Kubernetes cluster. And then they put it in and there's like 200 different microservices and they've all got access to each other. And then it's broken down and then it becomes a big load of microservices numbers. And you lose sight of what you're actually doing, because now when you go, well, how's your organization actually split up? What are the various different business units, and who cares about something? You know, who actually, as a person, owns that one individual cluster? No one does. You end up with an executive product committee of 3 people that owns a massive cluster, and then that doesn't work. And that to me almost always aligns with what you're chatting about, where things become really messy. So I would cut down clusters as much as possible, and that's why you get this load balancer coming on in. That's your fail safe. You know, you can always run a load balancer. You can have a cluster, you whack some domain names on there, and then you have a separate cluster for each individual unit. I can go into some examples of a few bits and pieces, like, for example, when we're talking about a gaming company, I'm going to use a gaming company because they have latency that they need to handle. What you would have is you would have an incoming load balancer that would be here, and then you would have probably traditional EC2 or VMs for really high frequency API trading. And then you would have a cluster over here for, say, internal applications, which would be things like, you know, HR systems, payroll, reporting, things like that, email servers, Confluence. That should be in its own little cluster to one side. You might want to split that up more. Then you might have another cluster for, say, things that are around your actual betting website front end, the pretty stuff, the HTML, the pages. And then you might have a different cluster for like really sensitive stuff. So your PII or your databases or things like that. And I would say that's a better way of splitting it up, because you probably have a finance or payments manager, a chief of that, who wants to look at his cluster and go, that's my set of servers that deal with all the stuff that in my part of the business we care about. And you don't have one big cluster that keeps payments and maybe a bit of internal and then also some high frequency stuff. It just gets too large. And when you've got too many people that have too much ownership of one thing, that's where it gets messy. Gets messy politically, but it's almost always guaranteed to be messy technically as well by that point.
Thanks for sharing.
No problem.
Any other questions at all for Andrew?
No, that was great. Thank you.
You're welcome. Any queries at all or anything like that, by all means, get in touch with Jack and we'll be happy to, you know, talk over it, because it's a lot that I've condensed in quite a small amount of time. And as you're kind of getting, I think, from the questions, which is I'm hoping what I'm putting over, is that this is another tool in the tool set to help you orchestrate as you like. What's the music that you want to play? This is a way that you could do it. So yeah, absolutely brilliant tool. I use it personally. We use it a lot of places, but there's definitely just that element of how can we utilize it, and it's going to need to be coming and fit your business as opposed to the other way around.
Cool. Well, listen, thanks for joining us, everyone. If there's any other questions, like Andrew said, we can get them answered offline. Appreciate you taking your time to sit with us today. And yeah, Andrew, thanks a lot for running us through that. But yeah, I'll end
It's a pleasure.
now. But I appreciate everyone for joining us. See you
Thanks,
later.
Zach. Thanks, Andrew. See you, everyone.
No worries.
Take care.
Bye.